Hello everyone, welcome. I'm Giuseppe Maggiore and this is the course Introduction to React. Now today we're going to talk about state and hooks in particular. And well, you can imagine that data in a real-world application is not just read-only, and as the user interacts with the front end, the application needs to track what is happening in the form of a mutable state, so a state that changes to track what the user is doing. The state can contain all sorts of information, from information that is really visible on the screen in a sense, for example, the content of a form that is being input by the user, but also information that is more implicit and invisible. The internal plumbing of the application, as you might want to say. For example, the status of an API call, whether it's still loading, it is loaded in order to show a loader animation, whether errors have taken place, etc. The current user logged into the system, and much more. Now, state management is the core of all of our software development and software engineering activities. So, even in a much broader sense than just what is needed for React, whenever you're building software of any kind, state management is the core. Why? Because you could say that all we do has to do with ending up representing the correct information that we're representing and storing the correct information that corresponds to the will of a user according to our business rules. So, for example, we want to make sure that the database contains yet another order of a product because the user clicked on the right place, paid the right amount of money, etc. And if the interactions of the user do not end up representing the correct state you could imagine, well, the application has failed and we have a bug. So in a very real sense, the core of everything we do has to do with moving from one state to the from the initial state to the desired state, and everything we have around it, like the rendering, the way things look like, etc., is an incredibly important way to make the state change process visible and understandable. But after all, it all boils down to getting from initial state to desired state. And if this doesn't happen or doesn't happen correctly, well, we have an application that doesn't work. And in 2023, well, it's the end of 2023 when this video is being recorded, people do tend to take bugs very, very seriously. The tolerance for bugs, delays, etc. is basically zero. So for this reason, we should take state management and the software engineering surrounding it very, very seriously. The last thing I'm going to say about this is that, yes, there are frameworks and ways of working that kind of promise that we can turn state management into an easy-peasy task, and they show a to-do app, or they show a hello world level application where state management has been simplified. We had the Redux a few years ago, and that's dying. Now the whole world of React is excited about hooks. There's a very unfortunate simple truth. State management depends on the kind of information, the kind of interactions we're building. Thinking that we can simplify that just because we have a framework is unfortunately misguided. So yes, we will see how to use hooks. We will see how to use class components today, but we will move later on to more proper software engineering ways of managing our state. Moreover, today, well, first of all, today we are going to start the application. There we go. It is running. Let's make sure that we actually can open it. And there we go. Okay, so there are right now two main ways of managing state and attaching state to our components. One is hooks and the other is class components. Hooks are a new, very clean and elegant way of working, but they are quite recent. They have been released not a lot of time ago, and they can do almost everything that class components can do, but not quite. Class components are an older and much uglier way of doing things, of defining a component with its own mutable state, but they can do everything. So you will encounter class components in two scenarios. Older applications, which, well, if an application is successful and remains old and doesn't need to be refactored all the time, then yeah, I mean, there's nothing wrong with it intrinsically. and doesn't necessarily mean that it's legacy. And class components will also be encountered when we need to track more complex lifecycle events like component did mount, should component update, and so on. You would be right in preferring hooks, and we will focus on hooks whenever we can because they are more elegant and cleaner, but class components, ugly, whatever, they are more powerful and they are still encountered in a lot of applications. So we'll learn both today. Okay, now, in this chapter we are going to extend our application in order to make the products editable. So we start by making the single product editable, meaning that the user can toggle whether or not they're editing, and then can change the name, description, and URL, and then, well, the data gets saved. We don't have a backend, so we're going to sort of pretend that we can save the data. So let's head over to the product state definition. And we are going to make the products updatable. We will define an updater object. This is very important. It's also very important that we have our need splitting because defining the state and the state updaters in a separate file would mean that, for example, all of this logic would have survived the change from class components to hooks without having to rewrite all of this logic and all of these files. So that's actually quite nice. Keeping things separate and doing things in vanilla TypeScript is an approach that saves us from unnecessary refactoring and rewrites. As the world of frameworks in JavaScript and TypeScript keeps changing, we don't have to change everything to still be always spick and span up to date. Okay, now we are going to define an updaters object. And this updaters object will contain all the operations that are applicable to the product state. So a product, because this is the state of our product component. We can change the name, and okay, the name takes as input a name updater. Now we start with something that's a bit of a mouthful, so this is going to be quite long, and we're going to clean up this definition, don't worry. So the name takes as input a name updater. For everything we will use this updater concept, whereas we don't accept the new name, but we accept as input something that takes as input the current name and gives us the new name. Usually as you're typing, the user has one character, and so yeah, that character sort of gets added, and by representing these updater operations, we have the ability to represent these changes to the state. So instead of saying, yeah, we only deal in new states, which is very reductive, we deal in change, in state changes. And this is, let's say, recursively doable, because first we take as input the name updater, then we take as input the current product, which is a product, and then we return the new product. Oops, then we return the new product. Okay. Now, we take as input the current product, because most of it doesn't change. And on top of this current product, well, the name becomes the name updater applied to the current product dot name. Okay. Let's also allow the description to be changed for now. So description, well, this is of course the description updater. We change the description, we change the description. Okay. Now, this is kind of a mouthful, but okay. So once again, we get something that takes as input the current. Oh, sorry, mistake. The current description produces the new description. Then look, after we give a description updater, what we're actually returning is a product updater, because this thing takes as input the current description, gives the new description. And when we have that, we can actually embed this transformation into something that takes as input the current product and gives us the updated product. Okay. Now, actually, even though this pattern may seem a bit strange, first of all, you will notice that in React, setState takes always an updater as input. it is possible to provide a new state, but actually React is kind of gently encouraging and saying, no, please don't give me just a new state, give me the updater. So this is out of the box compatible with React since the very first version. And the second thing that's very important about this, so this is, let's say, React friendly, but also it scales. Because if here I have this string to string updater, and I turn it into a product to product updater. But then if I have maybe a product collection, I can have a product collection updater that takes as input a single product updater and then updates only that element of the collection. We can embed these tiny updaters. So we want to change the name, but the name of a product, so actually we're changing a product inside the product collection, inside a page, inside a whatever. And this ability to spot patterns that are generic and reusable turns an application from a series of tiny, all unique ad hoc solutions into a smooth, uniform, boring, beautiful, reliable, predictable code base. And it's time to use this. Let's head to the product component or product widget, because this really is the place where state and rendering are mixed together. Now I am wondering, yes, this is the right place. Now we are still going to return the the JSX.element, but before we do this, we're going to get the state and the state setter from useState, which is our first hook. A new state, well, takes as input a generic parameter, so what state are we dealing with? And we could say that we have as state the product, which comes from product state. Yeah, okay, now there's the usual stupid overlap, so we should really change the name of one of those, but I am once again not going to bother. So let's get the whole module as product state, and here product state.product, and now I can also provide an initial value, and the initial value will be props.product. This type argument can be inferred, can be guessed by the product that we pass as initial state, so we don't need to put the generic argument. Now you see that the state has type product, and set state has as type react.dispatch react.set state action of product. And the set state action, I like it because it really implies that it's one of these updater things that changes the value of well, one field of the product by taking the current product and giving us the next value. Okay, so useState gets as input the initial value of the state, then state is initially, of course, props.product, but every time we call set state, state gets updated, and now what we're going to do is we're going to use the state in our component. There we go. And if we manage to call set state, then the rendering of the product will be adjusted as you would expect. Now, an insanely important thing to remember is that the state variable needs to be immutable. So if you try to somehow force, I don't know, the name to change like this doesn't work. React needs all changes of the state to pass through set state. If we don't pass through set state, then because whenever set state is called, the React knows, oh, I need to re-render this component. It's very, very important. So yeah, nothing will work properly if we try to mess these things up. All right. So we want to make the name and the description editable. So once again, remember we're not doing styling yet, so this will look like crap. Okay, you've been warned. All right. So let's have an input of type text. The value will be state.name. And on change, this is where things get serious. We are going to get the new name, This will be e.currentTarget.value. Then we call setState. And what do we pass to setState? We will call the updaters of the product dot name, and in this case we say, okay, ignore the current value and just put the new name. Notice that with an updater it's always possible to say, okay, you know what, just ignore the current value, we don't care about it. But at the same time, if we want to, I don't know, add something that adds, okay, an exclamation mark, a button that adds an exclamation mark to the current name, then the updater will always have access to the latest version of the state in this variable, which then wouldn't probably need to be called, should be called something better than underscore. And do remember that this lambda, especially when dealing, and the value of the state, especially when dealing with asynchronous calls, might, the lambda might get a more recent value than whatever was in the state. So the state might get a little bit outdated, and indeed, especially when dealing with more complicated patterns, you might think, oh, the state is the latest, but it isn't, and that can screw you up to the moon and back. So indeed, let's always use updaters. Okay, and oh well, actually that would be it. So now we're also going to do the same for the description, and this will be the new description, and here we call the updater for the description. Oh, sorry, I don't rename the method, I just called it before. Okay, let's take a look in the meantime. Oh, there. Yes, because the change broke everything, but I have to undo it. Okay, very good. Now, one of the things we have to really realize is that there might be, so React kind of works in a very asynchronous way, and we really have to embrace this. Like, we call setState and we pass the updater of the state, but it's not going to be called immediately. It might be called a little bit later. So if we say, okay, console.log state.name here, there is no guarantee, and the React computational model does not make any claim that this will be the case, that the state will actually be changed immediately. So React has reserves the right to do all sorts of things between the moment you issue a request for changing the state and the moment the state is actually changed. And when the state is changed, then the render block is executed again. So we have to really imagine this thing to be saved as a requested operation by the user, and React will do it as soon as it can, but not necessarily immediately. So there is an asynchronicity to these operations. That's also why, indeed, when you register an updater like this one, you have a better guarantee that whenever this thing is executed, it gets as input the latest state instead of something older. So let's really keep this asynchronicity in mind. Okay. So now let's refresh the page, and we can see, okay, now there's well, we can say we can change the state. Again, perhaps not the prettiest. The fact that the state is being changed is actually guaranteed by the fact that the value of the input component is the state.name, and in order for this value to change, so for us to see what is being typed, setState is the only way to make sure that state.name changes. So just by virtue of the fact that indeed you can see my exclamation marks, or I'm going to put dots, this only happens, and we only see these changes because setState is being called. Remove setState, refresh a couple of times. Let me actually open the console, disable cache, so more, so then the updates work better. I'm trying to type, but nothing is happening because we're not calling setState, and so state.name simply remains stuck at the same value. Okay, now this whole thing with the new name, current target, etc. is kind of ugly. So you know what? We are going to make things a little bit prettier. We're going to define replace with function, which is generic. It takes as input a value, and the new value, the new value of type v, and then it returns one of these sort of updaters of v. But this updater of v, okay, it takes as input. So we take as input the new value, the current value, and then we simply return the new value, ignoring the current value. And this is a column, yes. And now what we can do, we can say, okay, description, replace with e.currentTarget.value. Now we get rid of a little bit of ugly code. Might even fit this on a single line. You might be wondering, but why can't we do something like this? Because inside the lambda, because this lambda will not be called immediately, will be called later, the current target will have already been cleaned up by React. So by calling replace with and then current target value, we're basically storing current target value. So we take current target value immediately. We store it inside this replace with lambda. So we pass it as new value. It is stored in the closure of this lambda. And then whenever name is called with this updater, the updater is keeping the value of current_target.value instead of looking it up. So even if e is cleaned up and current target is cleaned up, because these are proxy objects and we couldn't access e and current target, well, it doesn't matter because we have saved the value for safekeeping for the future. So this is this asynchronicity thing, and you know, it's very much there. So now things will work. So look, I can delete and do stuff. But if I were to go back to the previous version, we get a problem, because this says, okay, cannot read properties of null reading value, because e.currentTarget is null, because the current target is a synthetic object that React created and destroyed. And so we called setState. setState hasn't called the name updater, and so trying to access e.currentTarget.value doesn't work anymore in the updater function. All right. So from a React perspective, we're kind of done. But from a software engineering perspective, we're nowhere near. So first of all, this thing has to move somewhere else. Where are we going to move this? Well, you could argue that, well, this is something that is shared. And well, okay, it's something that has to do with state, and yes, okay, replace with, very good. So that's already something. Hey. Okay, and that is already something that we've cleaned up a little bit. But in particular, especially these definitions are actually very ugly. We start with the definition of a function. This is something that is that's glaringly missing from the world of TypeScript, and I really hope that at some point we'll have something have something better for this. So now it's possible to simply say that we return functions, so that we have a little bit less type drama. But then I'm also going to use this directly, and I'm going to say that an updater of an entity is a function from entity to entity. And updaters, well, updaters get a lot of mileage so as a type. Updater is used in plenty of places in the React content. Then we can say, okay, the name takes as input the name updater and returns an updater of product, which takes as input. And now look, I can delete most of this stuff. And the signature now contains, you could even consider, the signature now contains a lot of very clear information. and there is a very neat separation between the signature, which says, okay, you take an updater of string and return an updater of product, and then the implementation, and the implementation is kind of trivial, and the implementation is then unbothered by all these extra types. Okay, now let me do the same here. There you go. Here we are. Okay, and now things are a little bit cleaner. All right. Another thing that we might do is we might make our application a little bit less reliant on the inlining of types. So you could say that the name updater is an updater of whatever type the name has, and the description updater also does the same for the description. This is type safe because, well, if we try to put a description updater with the wrong type, like let's say that by accident we picked the wrong field and this ended up being a number, well, we can't take the result in description and we can't pass it description as current value. So we are kind of covered also in case we were to make a typo. We have some degree of protection. Now feel free to skip or ignore the next 5 minutes because it's very hardcore. But I'm going to show you something beautiful. All right, now imagine that we have an address, and the address is again something more complex. So we have a city, street, and a number. So yeah, whatever. Let's say that the number is number, even though there's always variations, etc. So might not always work. Okay. And we want to define, okay, so this we're going to change to the product updaters, and we want to define the address updaters. Of course, the address updaters will be, and you can see how relatively boring this ends up being. Okay, so we have the city updater of address of, okay, at least this little bit of type safety helps. City, updater of address, of course, current product.city, okay, this looks good. Then street, I'm going to change this to field updater so that I don't need to change the name every time. 4 to the wise, laziness is good. Finally, we have the number. Number. Okay, cool. So, if we want to make it possible to change the address of a person, you could define the address updater, which takes as input a field updater, which is an updater of product of address, which is an address, and I return an updater of product. Now, this I can copy again. I can take the address, the result of the field updater over current product.address. Okay, cool. Let's say that we have a person. And okay, it doesn't matter what person, I'm going to just why is it not happy? Oh, pardon. Let's say we have a product, and I don't care about the value because I'm not going to run this code. And let's say I want to change the number of the address. I want to increment it for whatever it is. The person moves, I don't know, to the next house. So I could say that product, new product is, well, product updaters dot address of address updaters dot number, take the current number, increment it by 1, and then of course I have to pass the current product, which is the product. There you go. But you could imagine, and now you see what I'm doing is I'm passing the address updater to the product updater. But this could be done at another level and another level and another level. This is what we call a widening. So we are taking this updater, which is just updating an address. So this little block of code of addresses of where the product is, oh yeah, I was thinking about a person, doesn't matter, where the product is kept. The point is we have nesting of structures. This address doesn't know if it's used in a product, a person, a company, whatever. It can be used anywhere. And in this case, we want to say, okay, but you are embedded inside the address. Your number always changes in the same way, but you are embedded in a product updater. So we perform this embedding. Or from another perspective, this we called a widening, because we have an updater of address, which is very focused. It updates the name of the address. So actually, this is the first level. We have the updater of a number. And then we say, no, we update an address. An address has other stuff. And we have this updater of address that keeps the city and the street the same, but only changes the number. So it's a tiny thing that we make bigger, because now it knows how to update a number inside an address. And then we have the address, and we learn how to update the address inside a product. We call this a widening. Let's capture this concept of a widening. Let's see if we can. So a widening takes as input an entity and a field, well, a field key, which extends a key of entity. So for example, we could say product and name, product and description, address and city, and so on. This constraint, type constraint, I refer to the TypeScript course if you would like to know more about these type constraints, but this type constraint will guarantee that we cannot make a typo. The moment the entity is specified, we have to specify a valid key of the entity. Okay, now, this is a function that takes as input an updater of the field. And returns an updater of the entity itself. This would be the concept, the core of a widening. So widening takes an updater of, let's say, city, and gives us an updater of address. So if I wanted to say that I want a widening of address and city, I could get address updaters dot city, and this actually has the right type, but updaters, address updaters of number has the wrong type, and you can see here the small little worm of annoyance. Okay, so you could say that the type of product updaters of name would be widening of product and name, and the type of product update of address updater dot number is widening of address of number, and so on. So now that we have found this little neat trick of representing a widening, let's define a simple updater of an entity and a field key that extends key of entity as, drumroll, we take f in field key, so it's just one but could be multiple, so we have to iterate all of them, and then a widening of entity and field and f. Okay, now, or we could say we force it to be the same, but no, I'd rather do f. Okay, so what will a simple updater look like? Because now this is a record that connects an updater to whatever that, a widening to the name of the field that's being widened. So, temp of type simple updater of, let's say, address and then city. And what will this be? Well, the value we don't know yet how to create, but in temp we have city, which is a widening of address of city. So this gets us input the updater of string and returns the updater of address. So we have this in the type. Now if we can generate a simple updater given just the field key, because this is the only thing we really care about, because we know how to embed it and all, then we might greatly simplify the definition of these trivial updaters, because now basically a simple updater of name will be this fragment here, the simple updater of description will be this, and the simple updater of address will be this, and then we just need to combine them together, and that's all we really need to do. All right, so deep breath. Now export const simple updater. So this is the thing that creates a simple updater. First we specify the entity, a comma, because this is a TSX file and otherwise TypeScript doesn't know whether or not this is a React element or not. Then we specify the field, and the field will be can be inferred if the entity is already known. So you'll see that we can make optimal use of type inference like this. Then field key, which of course needs to extend key of entity. Okay, now the field has type field key. Then what this is supposed to return will be a simple updater of entity and field key. And let's say that this returns null exclamation mark for now, but at least the types are okay, and the simple updater is accepting field key. Like if we put just number, then here we get an error, because simple updater only accepts things that are constrained to being keys of the entity, but we have all the constraints in the right place. Okay, now, well, of course the simple updater will need to build this record of things. So we take the field and we connect the field to something that takes as input for the field updater, which is an updater of entity of field key, and this has to return an updater of entity. Take as input the current entity and returns the current entity where the field has been updated by invoking the field updater on current entity of field. And this, unfortunately, and it breaks my heart a little bit to say it, can't be correctly type inferred by TypeScript. So we need to put an ugly cast promising that things are as we would like them, but okay, now let's see what is going on. Wait. Oh, there's a known. So we really have to ease TypeScript into accepting that. Okay, we know what we're doing. Okay, cool, very good. Now, this is something that you do only once when setting up something like this. But look at what you can achieve. You can simply say that we want a simple updater. The first type we have to provide, and this will be the simple updater of product. And now we just simply say, okay, I want an updater of the name. Oh, really? Come on. Okay. Anyway, we will have to move all these things to another file anyway. So let's move them up for now. Move them up for now, okay, but look at what happens. Then I can simply say I want an updater of the name, of the description. This is all type safe, by the way, and we do get IntelliSense because by specifying the product and closing the first lambda, the second lambda knows, okay, this has to be a field of the product, and so we have everything that's available in the product, and we can say, okay, you know what, let's just get everything, because now it's become so easy and so trivial that yeah, just one line for each and every one of these properties, of these updaters. And I could do the same and say, okay, simple updater of address, close the first lambda, then we get inference, and I can say, okay, and then of city, and now it's so trivial that I can decide to have all of the properties with default updaters, in case these were in any way desirable, of course, for the application. The previous syntax where we create the updater manually will absolutely still make sense. Why will it make sense? Well, because in some scenarios, imagine that you actually want to perform a change of field, but there's some validation, or you change a field and then another field is a counter of those changes, etc. So in that case, you need the full power of defining your own lambdas. So when we have these trivial updaters, which are very common, but they are not universal, like they happen all the time, but they are not the only pattern we have, then yeah, we can opt in when possible, and then we save a lot of code, and these things look super pretty, it's type safe, and I mean, come on, look, this is so lovely. But when we need more complexity or more semantic richness, no problem, we can just implement it. I'm going to remove the address now because we don't need it. This was just an example. And I'm also going, oh look, type safety, haha, line 24, there's an error, makes perfect sense. And I'm going to move all of this to a shared file where it belongs, because we're going to use the heck out of this thing. Let's go to the shared folder. Absolutely, this is state management. This will be the simple updater, yes, because the rest is just frosting on top of the simple updater. And I'm mildly confused as to, oh. Okay, very good. And now things, well, work again. Now let's verify that they actually do work again. Yes, and you can see I'm just typing, and the simple updater and the set state hook are doing their wonderful magic. All right. Now, we know all there is to know about React and about useState. And this is great. Now, we are going to move our attention to embedding our product state into a bigger and richer state, which will be the products state, so the state of the multiple products that we have now. Okay, so we want to make the collection of products editable. That is, we want to be able to add and remove products. And of course, this is not done at the level of the single product, because the product widget only has visibility over its own product, but rather at the level of the container of all the products. And for this, we have two options. We can put it either in the products widget, which is a very valid possibility, or we can put it at the level of the main content. And you know what? We're going to do it here. We're going to do it in the main content. Now, we start by defining, of course, the main content state. And the main content state will contain the products, which are, as we know, a map of the product state. Oh, well, let's get from products, product, and the product state, we get the product state itself. Oh, pardon, just the definition of product. How silly. Yes, so it's a map of the ID of the product into the value of the product itself. Very good. And of course, let's make sure, oh, this is something recent. The definition of map comes from the standard collection library of JavaScript. But actually what we do want is the map from immutable. There we go. This thing has screwed me up so many times that you just type map and you get no error, no IntelliSense, and it's generic in two arguments, the key and the value, but you're using the wrong one and then things blow up somewhere else. Okay. Then we define the main content state, and then here we will have the default state, which is a sort of sort of constructor in a sense, and in here we define the standard value or the empty value or initial value or whatever of the main content state. And here we also, of course, have the updaters, and we start with a simple update. With a simple updater over the main content state, which updates. Let's include it so that here we get the little magic of the install instance, which updates well the only available field, which is the products field. Of course, well, this products simple updater doesn't really say much because, well, what we really care about is the ability to work with the elements of the map, and this we can do more explicitly. So instead of just having a simple updater here, we can actually start defining more articulated updaters, such as adding a new product. And adding a new product, well, it's going to be widening. No, not a widening. Well, this is just an updater of main content state actually. We take as input the current state, and then well we call the products we call the products updater. So we don't even need to take as input the current state. Now we start with the products updater, and here we get as input the map, and we can set a new ID. So it's better to use the curly brackets to have a proper scope, because we need to declare the ID separately and use it in the key and also in the value of the product. And now we read this from UUID v4. Oh, we need to include it. Let's see. Let me be very lazy. Yes, so we just copy it from somewhere else. There we go. Oh, we don't have the UUID library. Let's get into the client folder. Yarn add UUID. There we go. We need this library in order to be able to generate valid unique identifiers. Okay, now yes, please do save. Main content. Yeah, whatever. Let's give it a little push. So UUID, we have it. Oh no. Oh, we are missing the type declaration. Oh, very good, no problem. Yarn add types / UUID. Okay, so I should have done it in the client folder. There we go. Okay. And oh, finally, we now have the library. Okay, now we have the ID. So finally, we can add to the map the ID, and of course, we can add the value of our product. So the ID shall be the ID, and then the name can be empty, the description can be empty, and the image URL can also be empty. Okay, so this basically just adds another product to the map with a proper unique identifier. And again, the reason why we need to declare the variable is that when we set, we have the key, and the key has to be equal, obviously, to the ID of the product we added. And if we would do this, of course, there would be a mismatch. All right. We could also add other utilities, such as, for example, remove product. And the remove product, well, here we have to be a bit more careful because, well, we do need an identifier. So let's say we get as input product identifier. And as you know, I don't want to rely on having to say here what the type of the product ID actually is. So I always get it from the product type itself. Here again, we reuse the main content state updaters dot products updater when defining my simpler derived updaters, and here I can simply say remove product ID. There we go. Pretty, isn't it? At least I think it's very pretty. Okay, so we have remove product, very nice. I'm going to add another updater which is certainly going to be useful, which is just the updater of a single product. So the updater of a single product, what does it do? Well, of course, it takes as input a product ID, because we need to know which product do we want to update. And then, well, the next parameter we accept is an updater of that product, if it exists. And then we embed this updater into the updater of the main content state. We cannot really use a widening here because there is one step in between. So we have an updater of product, and the updater of the product goes through the updater of the products, and the products become an updater of the whole main content state. So we wouldn't have this double step, we would have a more proper widening if we had decided to put the products into the products state, but yeah, that's something else. But it doesn't matter. Okay, so we take the product updater, and this is our input. And the product updater, if we hover on top of it, it's just the updater of product. And now, well, we can call, as is often the case, the main content state updater of products. Then here in underscore we have the products, and we can check if we have the product ID, then we can actually do something with it. Otherwise, well, this updater cannot really be executed, so I already put the sort of escape clause. So we just return the map of products as it is, because we're trying to update a product that doesn't exist in the map, so there's not much to do. And this is, in my personal opinion, slightly better than throwing an exception. So we make sure that, well, we always return something reasonable to keep the application as intact from the data flow perspective as possible. Okay, anyway, so if we have the product, then we set in product ID the product updater over underscore.get of product ID. And because underscore.get of product ID isn't certain that we're actually going to be able to find the product ID, because it's not smart enough to connect, that we just checked if it's there. So we are already in the then branch of this conditional, so we are definitely going to get a valid product. But doesn't work, or TypeScript is not yet smart enough, so we put the exclamation mark, which is in general very unsafe, that says, okay, dude, I really am sure that the product is there. In this case, it's fine. We're not really breaking type safety, even though we're using a potentially type unsafe operator. Okay, now, of course, this needs to be moved away to the main content state. So let's do it. Move to File, enter new file path, and then we are okay. It points to main content state. Very good. And now the structure. So we have the main content state, like we had the products and product state. Very clear, very standard. So our code base is still very uniform. Okay. And now in our main content widget, this of course we return, and we have to use our state. So we define the main content state and its corresponding set state function, and this will come from the React use state hook. But what is the default value of the state? Because otherwise here state can be undefined, because the thing has no clue what the value of what the type of the state is going to be. Now we get main content state or undefined as a result, because we specify the type, but, well, in the beginning, the very first value of the state will be undefined, but then we have to carry this undefined everywhere in all the set state actions, which are just updaters. So we simply say that the initial main content state comes from the default function, and now you can see that this new version of useState, because we always have, starting from the very beginning, a valid non-undefined value of the main content state. Now the type of the state is main content state, and set state also deals in main content state rather than main content state or undefined. Okay, very good. As we deal with our products, for now, what I'm going to do, and this is not the prettiest, we're going to introduce, we're going to remove this level for a moment, and we're going to inline it here temporarily. But now the products come from the state. And of course, we do need to include the product. Okay, very good. So here we have all the products in a product block. We are actually going to make this a little bit better. We're going to create an unordered list with UL, and then every product will be inside a list item. Then we are providing a slightly better structure to our for our application. And I'm going to put the key just one step higher. But inside every list item, I'm also going to add a delete button. And I'm just going to call this delete product. And the delete button obviously deletes the current product. So let's add the on-click event handler. It doesn't really matter actually what we get as input, because we're not really going to work with the event handler. We know already product p.id needs to be deleted. We call set state, and what do we pass to set state? Well, we say what to do. And what do? We want to run an updater of the main content state, which is remove product. Which product? p.id. And there we go. Let's test this. Well, oh. Of course, now the default state starts empty. I'm going to use the sample products. And we need to get the identifiables to map, because otherwise this has the wrong type. Yes, very good. Let's try this again, and there we go. Okay, now you notice that, okay, despite my pathetic styling, it's going to be marginally better later. We do have the delete product button. Okay, we have the console, so if things blow, okay, nothing blew up. It's very nice actually. Tuck, tuck, tuck. Okay, of course nothing is happening. So in permanent storage, so if I refresh, then obviously the products are back there. And the React state now reflects the user interactions and the will of the end user. So we are making some actually pretty good progress. Let's also add a new button at the end of the whole list. We're going to add a button that says add a new product. Well, and add a new product will simply invoke add product. Let's test this, of course. Let's see, no compiler errors, everything looks happy. Let's refresh, so we can delete products, but we can also add a new product. And now you can see, well, of course, pardon. Well, whatever. We can add and delete new products. So a new product, this product is absolutely awesome. Okay, we cannot edit the images, the image URL, so we cannot place put a picture, but you know, for now, for the purposes of today, well, it's good enough. Now, unfortunately, I have to show you something ugly. So the next bit looks really ugly, and I'm sorry for this, because hooks are so simple, clean, and elegant, and what we're about to see is fugly, complicated, hard to read. But the first version of React did not feature hooks. Rather, it featured a very Java style, everything is a class or an object oriented setup that was required for state management. And unfortunately, this kind of legacy is still very relevant nowadays. It's still very relevant because it's more complete than hooks. Hooks are catching up, but not yet. I'm going to do this in the index, just because we're not going to use this unless we can't avoid it, but I want you to have seen it at least once. React exists for so many years already that even if you get a job as a professional React developer, you will have to deal with this. So yeah, sometimes software engineering, especially if you work for a successful company might be 10 years old or 20 or 30. So it might be that they have valid, still working, slightly non-cutting edge solutions, and it's just good to be able to deal with them. Okay, anyway, so let's say we want to build a counter, okay? And let's say that we have properties, of course. So the counter properties will simply define the initial value of the counter. And then we have the counter state, which is just the current count. So, and the counter state will change as the user interacts. Okay. Now, we create the counter, and the counter extends React.component, which is generic in 2 arguments. The counter properties and the counter state. And seeing this should make you feel like you respect your elders more, because this is what we had to deal with years ago. You know, you get hooks and we got this. Anyway, okay, so and now we need a constructor. This thing just hurts me almost physically. Okay, and the properties it gets are the counter properties, and then we initialize the state. We call the base class constructors the constructor of React.component, and we just forward the properties to this, and then for the state we say that count starts at, well, props starts from. Very good. And now we have a render method, and render will return, in this case it's just good to be a button, and the button will show the current count, so this.state.count, and in the onClick method of the button, then, well, again, it doesn't really matter to get the whole object with the current target and information about where did the event take place. Here we can simply call this.setState. So this is the original set state. That's also why in many cases, if you go to the main content state, to the main content widget, here I call this state and set state, and that's just a wink to old style React, but actually we could say, no, this is the main content state, and this sets the main content state. A lot of people still call this a state and set state in loving memory of the fact that here we were stuck to this.state and this.set state. Anyway, okay, here we produce an updater. So in this case, again, we can produce an updater that takes as input the current state, which is called underscore in this case, and then I say that the count is underscore.count plus 1. Of course, the very same policy of defining state updaters works here. We're actually going to do it. Const counter state, and then the updaters. Then, well, let's say incr. And what does incr do? Well, it just produces an updater of counter state, which actually, we can obviously use a simple updater. I mean, why not? Simple updater of counter state. So here, obviously we don't have the updater here. Let's update it. Okay. So now we call counter state dot updaters dot count, and here we can simply provide just the increment of 1 to the counter. And we can do incr twice, decrement, whatever. But the reason why I'm doing this is that this way we can keep that neat and super important for survival, at least of our quality of code base, the separation between the component itself and its business logic and the state management, so that if a front-end developer needs to change all of this, which is layout, they can do it freely without having to muck around with, let's say, the more back-end related business logic. So here we can call counter state dot updaters dot incr. A very important note about this is that I started working with this kind of pattern many years ago, the updaters and the definition of the state, and one of the cute things is that if you work with a pattern like this, then you're doing software engineering, and this has survived the fact that well, first we had just React, then we had was called flow or flux. Then we had the Redux, and we have Zustand, and the context API, and hooks, of course, etc. One of the cool things is that by working in a software engineering with a software engineering approach, then a lot of your business logic is written in a style that is eternal, like actually properly, well, if not eternal, you can write code that is going to last 20 years. So if you have such an ugly component and all of a sudden there's the hook there's the whole hooks API, and you're like, yes, I want to refactor to the hooks. That's great, they look fantastic, you know, and then you refactor, but at least most of your business logic is neatly tucked away in a safe place, because if you look at this has nothing to do with React. This is just a normal code, normal software engineering, normal TypeScript, etc. Let's put our counter. No, I think it will work, but it's always a good idea to test. Let's refresh the page, we see the counter, and bam, there we go. Okay, looks good. All right. I don't know if this makes sense. I'm going to add a +1 here. Okay, so 10 plus 1, that's 11, plus 1, 12. Oh, okay. All right. You can clearly see I'm not a UX designer. And of course, here you would also be able to neatly split this bit into a layout file, but we're not going to go this far. In here, we have a bunch of hooks. Component did, no, not hooks, pardon, component lifecycle methods. We have component did catch, did mount, did update, will unmount, should component update. The ones that are stricken through are deprecated. Those really shouldn't be used. But you can see there's 5 very important component lifecycle methods, which not only are not deprecated, but are very, very useful. So component did catch will be invoked whenever the component throws an exception. So you can use it to build so-called error boundaries, so that you can actually control what the user gets to see when there is an uncontrolled, unmanaged, uncaught error, an exception somewhere in your code, be it render or be it something else. Component did mount happens when the component is mounted in the DOM for the first time. And that can be very useful when, for example, you want to trigger an API call only when the component has been mounted for the first time. A component did update is called whenever a component is updated, so is rendered again. Component will unmount is when a component is about to be deleted from the DOM. And should component update, which is absolutely essential together with component update for managing when and how components are re-rendered onto the DOM. Should component update gets as input the previous properties and the current properties, and of course the current state, and may decide whether or not the change in properties should warrant a re-render or not. By default, React will re-render every time. And this can be very heavy. But you could decide that when some properties change, for example, if we have the products component and the user property has changed because the user logged out or logged in or whatever, we don't need to re-render the products, because it might be that the products are supposed to stay the same, so we skip the re-rendering of all the products based on the value of should component update. Should component update can be, in a sense, replicated with React.memo, but with classes we actually have more control over what these things mean. So if you want to gain full control over what components do, not only as they render, set state, etc., but also as they are inserted or removed from the DOM, then class components are an invaluable tool. All right, now that's all for state management with hooks and also stateful classes. I'm going to remove this old style component. It's there, you know how it works, good for you, and I wish you never to have to use it. Okay. So for the rest of the course, we will stick to hooks whenever possible, and yet actually you will see that neither hooks nor stateful components are the most useful state management pattern, but that will be the topic of the next lesson. Thank you very much for being here, for following through, and until next time, bye bye.